Hey guys, welcome to Collision PSD series, and today we're gonna cover collision in depth. So let's start. So the first thing I want to do is I want to categorize collision into four. No, there's three types of collisions. The first one being elastic collision, second one being inelastic collision. This one's perfectly inelastic. Perfectly inelastic is wherein the particles stick together. So it's perfectly inelastic. Here, the key point is that they stick together and they move as a whole. Stick together and they move as a whole. Move as a whole. The third type of collision is just inelastic collision. It's not perfectly inelastic. That is, there's some amount of loss of energy. Some amount of loss of energy and shape. So the energy and shape has been degraded. I'll go in depth, okay? So let's start with inelastic collision. Inelastic collision. Okay. So let me define the term coefficient of restitution here. So coefficient of restitution, also represented as E, this is E, is basically different for different surfaces. And this is just a number that you guys have to remember. There's no concrete definition for this. It's E, and it varies between 1 and 0. So E is different for different cases. For example, it's different for inelastic, it's different for elastic, it's different for perfectly inelastic. So for uh, elastic collision, right? So for elastic collision, the E is 1. That is, there's there's zero loss of energy. And so let's take an example, okay? Let's say this is mass m1, this is mass m2, moving with velocities u1 and u2 initially, and then after collision, because this is elastic collision, so each one of them is going to have independent velocities because they do not combine. So let's say the velocities are v1 and v2. Now v1 and v2. So in order to find u1, u2, v1, v2, or stuff like that, we use two types of equations. One is, so there's basically two main rules to remember. One is conservation of energy. Second is conservation of momentum. Conservation of momentum. And the third is derived from energy itself. It is velocity rule. The velocity rule states that let v2 and v1 be velocities after collision, u1 u2 be velocities before collision. Then I can say that v2 minus v1 equals to e times u1 minus u2. And remember, u1 minus u2 are basically have to put in the same order. U1 is for the first object, V2 is for the second object, V1 is for first object, U2 is for second object. So I'll show you an example. It'll be even more clear for you guys. Yeah, it's going to be even more clear once I show you the example, but just remember this. One is the velocity rule, which is V2 minus V1 equals E times U1 minus U2. And this second one, which is the momentum rule, this is quite easy. So the momentum of a body is mass into velocity. Momentum of m1 is m1 u1 initial momentum, m2 initial momentum is m2 u2. After collision, the momentum is m1 v1 plus m2 v2. This is one rule. This is the other rule. Now, because there's two variables, two equations, because either v1, v2, u1, u2, any two of them have to be given for you to solve. So there's two variables, two equations, and you can solve this any unknown value which is asked. Okay. So just so the main thing in elastic collision, this was elastic collision, is that E equals 1. So here you have to put E equals 1, and you have to rearrange this, which becomes V2 plus U2 equals U1 plus V1 in elastic collision. Just remember this. If it's an elastic collision, then this rule can be used. Okay. Okay, now let's go to inelastic collision. Right. So let's rewrite the equations which we talked about. m1u1 plus m2u2 gives m1v1 plus m2v2, and v2 minus v1 equals e times u1 minus u2. So whatever it is, like if it's 2 minus 1 in the v, then in u it's 1 minus 2. If so, or this is similar to v1 minus v2 equals e times u2 minus u1. Just remember it this way. It's not that tough, guys. Okay, so now let's talk about what if the masses are same. So if the masses are same, let's say this is a mass m moving with a velocity v in this direction. This is a mass m also moving with a velocity v dash in this direction. Then after collision, the velocities of equal masses get interchanged after collision. After collision, the velocities get interchanged. So here, this is mass m as well. This is mass m too. So now when the collision happens, this is the after collision case. This is gonna move with v dash. Yeah. So the velocities get interchanged. The velocities get interchanged along with direction. Even the direction of the velocity of the other particle is transferred to this one. So let's say m was moving with v dash. The other m now moves with v dash in the same direction. That is the direction of the previous m, along with direction. So direction also gets transferred. Okay. There was a really easy PYQ on this as well. So I mean, you guys can solve questions if you guys listen to my theory, because this is crisp. This is actually quota theory. This is the one which they teach in quota. So I've seen the notes, and that's what I'm telling you guys. This is a very important and easy theory. Just see this, and then any question is possible for you. Okay. Now let's move on to, yeah, and then this after case, this m moves with v dash. Sorry, this m moves with v velocity. This m, and this m moves with this. This m moves with this. Yeah. Now let's move on to inelastic collision. Inelastic collision. Perfectly inelastic collision. Okay. So in perfectly inelastic collision, the key point to note is that the objects that combine, the objects basically get stuck. They get stuck and they move as a whole. And move as a whole. They move as a whole. This is the main thing to remember. Okay, now let me give you an example. So let's say this is m1 moving with velocity u1. This is m2 moving with velocity v2. u2. Then they combine, so this becomes m1 plus m2 as a whole, and then they move with a velocity v. So here the two equations become a first of momentum, which is m1 u1 plus m2 v2 equals m1 plus m2 into v. And the second one is for v2 minus v1 equals e times u1 minus u2. Here the u1 and u2 exist, but here the v, the u v1 equals v2 equals v. So now when you use this, yeah. Another thing to remember is that e, the coefficient of restitution, equals 0 for this. Now when I put e equals 0, notice I'm gonna get this gone. I'm gonna get v2 equals v1 equals v through this as well. So coefficient of restitution equals 0 in perfectly inelastic collision. And objects combine, that's why v1 equals v2 equals v is what happens. And it was proved using this equation. So this is a very, very important equation, because in some questions you're given the coefficient of restitution as a decimal number, because it ranges between 0 to 1. So when you're given the coefficient of restitution, you got to put it in this equation and then solve. So this is the main part which I wanted to bring to you guys. Now, should we actually practice a question? Okay, let's do inelastic collision and oblique collision, and then let's jump to the question straight away. So for inelastic collision, this is not perfectly inelastic. This is only inelastic collision. So for inelastic collision, wherein the, the coefficient of restitution lies between less than 1 and greater than 0. In the previous cases, it was 1 and 0. Here, it's less than 1 and greater than 0. So let's see. Uh, yeah. So in inelastic collision, we use the same equations, the same rules, and solve. Nothing special. Now I want to bring to you guys a very important part, which is when there's a surface here, right? And let's say from a height h, I've dropped a ball. You guys must be knowing the velocity with which it's gonna hit, right? Which is, let's say, u1. Now the ground has a u2 equals 0. The v2 of the ground is at 0 as well. After collision, it bounces back up with v1 and goes up to a height h, let's say. H is somewhere here. Now it's quite obvious. Let's say the coefficient of restitution. Let's say the coefficient of restitution of the surface is E. It's quite obvious that once it goes down and comes back, it's not going to achieve the previous height, whereas something lower than the previous one. So here, let's find three paths. One is u1. Let's find u1. Second, let's find v1 in terms of u1. In terms of u1, and let's also find height h in terms of h. Okay, so this is very, very, very important, and this should not be skipped. Trust me. Now let's move on, because this is the key material which I'm teaching you for PYQs, and we're gonna do a lot of PYQs, which is gonna show you why theory was so important. Okay, so let's see. So let's find u1. So we can use kinematics. We know that when an object falls from height h, its velocity was 0. Initial velocity was 0. So I can use the equation which states that v square minus u square equals 2gh. So v equals root 2gh. Not v, sorry, u1. Yeah. So u1 here is our root 2gh. Quite obvious. We studied this in kinematics. Now let's see what is v1 in terms of u1. So remember what I told you, that we can use the v2 minus v1 equals e times u2 minus u1 minus u2 equation. Here, just put in the data. So so what is v2 here? V2 is 0. V1 is v1 e times u1. What is u1? U1 is root 2gh minus u2, which is 0. So I can say that v1 equals minus e times root 2gh, which is v1 equals minus e times u1. And minus here, the minus sign here indicates direction. It indicates direction. That is, it is opposite. It is basically, because the v1 velocity is in this direction, which is negative. This is the positive direction. So it's basically opposite to the direction of u1. It's quite obvious because there's a rebound. So after rebound, it goes up, whereas the u1 was downwards. Yeah, that's quite obvious. So the magnitude of v1 equals to e times u1, which is same as e root 2gh times e, right? Now this is important right here. Okay, now let's move on to something which is h in terms of h. The height h, which it goes after the first rebound in terms of h. So we just found v1 in terms of u1, which is coefficient of restitution e times root 2gh. Now let's see what is going to be the height h to which it rebounds. Now we can use the simple formula, which is wait, s equals ut half a d square. No, we can use v square minus u square equals 2gh. Here v is 0, u is this, so u square, which is 2gh times e square, equals 2 into g into height h. So you see I get height h equals e square h. So the height h which it's going to reach here after the first rebound is equals e square, coefficient of restitution of the surface is e square times height h. So the coefficient of restitution square times h. H was the previous height from which it fell down. Now this is done here. So h equals e square h. Now the next time it goes down here and comes back up, it's going to be e squared times h, which is e4 times big H. Okay, now I hope it's clear. Now let's jump to oblique collision. Yeah, oblique collision is a very important topic, and this has come in JEE Advanced 2023, and I'll be solving the question in my PYQ series. You guys can check it out. Let's go to oblique collision. Yeah. So the first term I want to define is line of impact. What is a line of impact? So line of impact is perpendicular to the surface of contact. Keep this in mind. Line of impact is perpendicular to the surface of contact. Let's say this is a surface. So if this is the surface, and let's say here's a particle which was thrown like this, strikes the surface, and if this angle right here is theta, so this is u cos theta, agreed? This is u sin theta. Sorry, my bad. Because the direction here is downward, the u sin theta has to be this way, and u cos theta has to be this way. Now remember this. So line of impact is perpendicular to surface of contact. So this right here is the surface of contact. This is surface of contact. Perpendicular to this is this, which is the line of impact. So surface. So line of impact is perpendicular to the surface of contact. So this is the surface of contact. Perpendicular to this is this. And remember this point. In oblique collision, the component of velocity, the component of velocity perpendicular to the the line of impact is unchanged, or it remains unchanged, whereas the component of velocity which is in the direction of the line of impact, it gets changed using the coefficient of restitution law. We can change it using the velocity law which we studied which we used for this collision right here, and we stated that v1 equals e times u1. We can use the same law here. So if it's u cos theta in the downward direction, so this becomes, after, if the coefficient of restitution of this surface is e, right? So if the coefficient of restitution is e, then we can say that after it rebounds, the velocity will be eu cos theta in the upward direction, and here, because this part of the velocity, which is u sin theta, is perpendicular to the line of impact, it's gonna get remain unchanged. So therefore, now the two components after collision look something like this, and its velocity is going to be this way. So let's now see what is v. So v is e square u square cos square theta plus u square sin square theta. Now I can take u square common and root of this thing, because it's more like this, right? This here is the resultant of two perpendicular vectors, and the resultant of two perpendicular vectors is, let's say a is in x direction, b is in y direction. It's a squared plus b squared, the root of this thing. So that's what I did. E square u square cos square theta plus u square sin square theta. This is eu cos theta, because when u cos theta was in the direction of the line of impact, then it gets rebounded back with the speed of eu cos theta, which we just studied here. When we said that a ball is dropped from height h, it goes down with the velocity u1, then it rebounds back with a velocity of v1 in the upward direction. We just did it. So the same thing can be used here. And now when I take u square common, so it becomes u into e square cos square theta plus sine square theta and the root of this thing. So there you go. This is our final answer for the velocity with which it goes back. Okay, so here you see why coefficient of restitution is so important. Okay, now let's so the two main points are that component of the velocity perpendicular to LOI remains unchanged, and the component which is in direction of the LOI, it becomes EU cos theta. If it gets multiplied by E, and it changes the direction to the other one. So if it's going in the downward direction, then it goes to upward direction after that. So I hope this was clear. This is the theory which you need for solving any question you want. Now let's solve some PYQs as I promised. So let's see what this says. It's a JEE Main 2023 PYQ. I mean, it's not that tough, but let's see what it is. And I've put a little bit of tricky questions as well. And there's diversity which I've tried to cover. different type of questions. So let's see. A ball is dropped from a height of 20 meter. If the coefficient of restitution for the collision between ball and the floor is zero point 0.5, as I said, they're going to give you the coefficient of restitution in every question. After hitting the floor, the ball rebounds to a height of dash meters. How easy can a question get? Like, tell me. This is the surface. A ball is dropped from a height of 20 meter. If the coefficient of restitution for the collision between the ball and floor is 0.5, after hitting the floor, the ball rebounds to a height of what? I said h equals e square h, where this is h. Now e square is 0.25, which is 1/4 of h. H was 20 meter. So h, which is new rebound height, is 5 meter. I mean, look, this is a 10-second question if you knew the theory. Okay, now let's move on. Or you guys can use if you guys don't want to remember the result too quickly, you guys can use the simple formula and say that let this be u1, this is e times u1, and then you guys can find eu squared 2gh, and then cut this part, and then h equals eu squared h, and then at the end you can get this as your answer. Okay, now let's move on to the next question, which is this one. So I haven't explained this theory yet, but it's quite obvious. I mean, this you guys can use conservation of momentum, right? Which we studied in your Newton's laws of motion. Shouldn't be that tricky. So here they're saying that a stationary particle breaks into two masses, ma and mb, which move with velocities va and vb respectively. The ratio of their kinetic energies kb is to ka is. Okay, so if it breaks into two parts, it was stationary. So momentum initial, right? So momentum initial equals to 0. So momentum final equals to 0 as well. So ma plus va equals to ma vb. Okay, and now the ratio of the kinetic energies, which is half ma va square, is to half mb vb square. So now ma va equals mb vb, half half gets cut, this gets cut, so it becomes va is to vb. Where basically vb is to va because it's kb is to ka. So the answer is this. And for this one, the answer is 5. Okay, now let's move on to the third question, which is a body of mass 1000 kg is moving horizontally with the speed this. If 200 kg extra mass is added. So here, same thing, conservation of momentum. If 1000 kg moves with 6 meter per second, momentum is 6000. Now 200 kg is added, so it becomes 1200. Momentum stays conserved, velocity is 5. That's it. Stick to your basics and everything's possible. Now I'm just solving 5 questions here, but if you want to know all the 20, 30 questions, you guys can check out the PYQ series. It's right under the PSD series. It's there, like it's in the same playlist. It's exactly in the same playlist. All you got to do is scroll down the playlist and then you're going to find it. As per the given figure, a small ball P slides down the quadrant of a circle, hits the other ball Q of equal mass, which is initially at rest. Neglecting the effect of friction and assume the collision to be elastic, the velocity of ball Q after collision will be. Okay, quite an easy question. If this is so, this has got to be 20 as well because it's a quadrant of 20 centimeter radius. Now, if this is as per the ball, so it's equal mass. It's left from rest. So as you know, when this falls down, all of the energy gets transferred here. Now it had m into g into 20. Let's say in meter, it's 1/5. So this was the amount of energy it had initially at as potential at a height of zero point 0.5 at zero point 0.2 meters. Now that this is transferred, the velocity of q after the collision would be okay. So g by 5, which is 2, it should be 2, right? It's 2 because all the energy that this has is going to be transferred to this, and because the masses are equal, this mass has velocity equals 0. So this, when they collide, equal masses, when they collide, they switch velocities. I just discussed it. So if this switch velocity is this switch is at rest initially. Now when this hits this is gonna get to rest. So the after scene is gonna look this way. This is gonna be at rest afterwards, and mg by 5 energy is gonna go to this one. So it's gonna be 2 meter per second speed is to this one. So the answer is D. Okay. Now let's move on to the last question, which is a particle of mass m moving with a velocity v collides with a stationary particle of mass 2m. After collision, they stick together and continue to move together with velocity. Such an easy question. Momentum stays conserved. Just one thing. They stick together. That means the new mass is going to be 3m. This is a perfectly inelastic collision, which means E equals 0 and V1 equals V2 equals V. So 3m into v equals initial momentum, mass m, velocity v. So therefore we can say v dash. Let's say this is v dash. So 3m v dash equals v by 3. That's it. Thank you for watching. And the PhD series for collision is done. Now the PYQs, which are 20 PYQs that I'm going to discuss, is right below this. Go check it out. Right below this in the same playlist.